Hello students, welcome to my YouTube channel UPSU Technical Center once again. Today's subject is electromagnetic field theory as per MACOUT syllabus. Last class I have already discussed introductions. Here I have already displayed. So the vector analysis, scalar quantity, vector quantity, and I have also discussed the very important example. Current is a scalar quantity or vector quantity. Okay, so without losing any time, so I think we must go through the new topic because the time is very short. Today's topic is unit vector. Okay, very important things. Now we consider the expressions over here. Okay, to minimize the time, to reduce the time, and to total utilize the total time, I have already written everything, but each and every point I will discuss. Okay, in this first line, I have mentioned expressions. This is the expressions for the rectangular coordinate systems. Here it is a vector A. Suppose it is a vector A, and it is the presentations. Here ax, ay, az, all of the coefficients a, ix, iy, iz is the unit vectors. The presentations of a unit vector for a particular directions. Suppose I, yeah, it and any other books it may be u, it may be small a, small u, small a, whatever it may be. That all are determined. All are defined for the unit vectors. Here I prefer to use I. Okay, ix, that is the unit vector in a particular direction x, iy is the unit vector in a particular direction y, iz in a unit vector in a particular direction z. It is a very simple things. Now I want to calculate ia, so very simple way you can say that is the ia, the unit vector in a particular directions. Ia direction, that means a unit vector of a in a particular directions. In which directions? A directions. Okay, now the formula of the unit vector is that you just write down the vector of a in the numerators and and the modulus of this particular a. This is the ratio between the vector and the modulus of that particular vector. So you can write down the modulus of those vectors. You just take the coefficients, square in each coefficients, sum up that value, and afterwards you do the square root. So square root of each coefficient square, sum up of this coefficient square will give you the value of mod value. Okay, now just put these values in place of a vector. You just copy the vector expressions, and in place of modulus of a you place these expressions. Okay, so very simple things. This is a very important. So here this is the expressions. You can say this is the expression, you can say it is a formula of a particular vector. Now what is the value of unit vectors? 1. As it is called unit, that means its value will be 1. Importance, what is the importance? To specify the direction of a vector. Whatever a vector, suppose here is a vector, I will put an arrow over here. This arrow for a particular vector, suppose it is a vector f. Suppose f means force. So this force is a vector and it is denoted by a unit vector I, and it is f, so you can write if. So this unit vector will give you the direction in a particular direction of force. So it will specify the direction of that vector, of a vector. Which type of vector? Here I have considered force as a vector. Now example here we want to say, if we multiply a vector with a unit vector, if we want to multiply a vector with a unit vector, then the vector direction is changed to a unit vector. Suppose here a vector a f is there, so now we want to multiply by ia, that means ia means here. So when you multiply this vector f by ia, this vector will be directed to the ia directions. This is the things. Unit vector change the particular vector to a specific directions. In which directions? Ia direction, unit vector directions. Okay. Next things, suppose we consider a numericals. Numericals, here is the numerical, so B is there and you have to calculate the IB. What do we need to do? So very simple things, and formula, you know, this the formula is that, what will be the formula? Formula of IB equal to vector B, okay, and the mod of B, vector B and the mod of B. So put the equation, put the vector equation, here is the Ix and 4Iz over here. Okay. Next, the mod value, you just take the coefficients here. No coefficients, no need to mention the coefficients of sorry, Iy, because Iz is not there. So here will be the value of -5 to whole square. Next 4 the whole square. You will get the answer. So -5 Ix, you just put the value of these things, 5 square, that means 25, and 16 and 25, how much will be? uh, um, 60 and 25, it will be 16, plus 25 plus 16, 41, root over 41. Okay, am I right? Next, plus 4 root over 41 Iz. This is the expressions of I, and this will be the formula. So very simple way you can calculate those things. Now importance to relations of unit vectors. Let us discuss about this. Just a minute. Unit vectors. Unit vector relations. Suppose for the Ix is the unit vectors. If we multiply by Ix, it is a unit vector and it is a dot product. What will be the value? 1. Next, Iy dot Iy. What will be the value? 1. Iz. What will be the value? 1. If we multiply Ix dot Iy, then it will be 0. Iy dot Iz, it will be once again 0. Iz dot Ix, it is once again 0. This is all about for the dot product between the two input vectors. If we do the input vector, same type of unit vector, same unit vector, after doing the dot product, you will get the value of 1. What is its reasons? What is its reasons? Reasons is that at the time of dot product, if we go through these, what will be the formula? That formula I will discuss at the time of dot product. Okay, let's wait. Next, in case of cross product, I will discuss each and every part later. That will give you 0. But Ix cross Iy, that will give you Iz. Last things I will discuss, Iy cross Ix, that will give you minus Iz. Each and everything I will discuss. Today I will finish my lectures. I think this lecture will be beneficial for you. It is a very small and brief idea. This idea is very important for your exam. Thank you very much. If you like this, you can share and give a comments regarding this. Thank you very much.